So now problem number 10. In problem number 10 it says an apple of 0.15 kg, an apple of 0.15 kg. It means if you just multiply it with 10, then this mass would get converted into weight. So its weight would become 1.5 Newton, and it falls from a tree. Okay, and at one point during its fall, its air resistance is like the air resistance on the apple is 0.6 Newton in upward direction. So suppose here is an apple which fall from tree, and it says at some height, like here, due to weight it is moving in downward direction like this. Due to weight it is going it is going in downward direction due to its weight like this, and air resistance is acting in upward direction. Let's assume that air resistance is acting in upward direction like this. So now you can see this is the weight which is downward, and which is moving it in downward direction, and at the same time here is 0.6 Newton which is in upward direction. 1.5 Newton in downward direction and 0.6 Newton in upward direction. Again there is a parallel case and both are in opposite direction. So we will find out, first we are going to find out resultant force, and resultant force is like the 1.5 is in upward direction minus 0.60 is in downward direction. So we are left with our resultant force is 0.9 Newton. Okay, so we know that force is m dot a, and mass is given as 0.15 times acceleration is a, which is equal to 0.9. Now acceleration is equal to 0.9 over 0.15. So it is approximately 90 divided by 15 is actually 6, and it is meter per second square. So our answer is this one. This is our answer. Okay, the rest of the options are incorrect. Okay, let's see number 11. 11 number is about Newton's third law. Like there are, see 4 of the gravitational forces, like there are 4 gravitational forces are given here that acts between bodies in solar system. In our solar system, like we have Earth, Moon, Sun and other planets are described below. Okay, the force on the moon due to Earth. So here is a pair between Earth and Moon. Okay, Earth is applying force on moon, so Earth is acting like this is the direction, like Earth is applying force on moon. Or in second case, see, the force on Earth due to sun, this is some different type of force. This is not similar to the above one. It's between Earth and sun. Okay, on the Earth due to sun, it means sun is like applying some force on it. Okay, next case, the force on Earth due to moon, it means this is quite similar to this one. In part P, like the force is on moon due to Earth. Now in R, it is on Earth due to moon. So you can say there is a Newton's third law, because in upper case it was kind of action force, and here it is a kind of reaction force. The force on moon due to sun, okay, it's a totally different case. Which of the forces are Newton's third law? So this one and this one, actually this one is action force and this one is a reaction force. So P and R are here. So rest of them are forces, but not Newton's third law, not according to the Newton's third law, in which action and reaction are present. In here in red one, there is an action force, but its reaction force is not mentioned. In S, there is a action force, but not its reaction force. So that's why we are not going to consider them. In case of number 12, it says a man pushes a heavy box along the ground. Okay, it means the person is applying some force, is the applied force is in this direction. Okay, a force acts between the man's hand and the box. Okay, it means there would be a reaction force that would act like this. Another force acts between the man's feet and floor. Like you can see, the man is actually applying force in this direction, and there would be a reaction force that would be like this. So red ones are action forces and the purple ones are reaction forces. Okay, in which direction do these forces act on man? So this force is acting on man in this direction, and this one is on this direction. On hands it is in leftward direction, on feet it is in rightward direction. So let's see the options. Force on man's hand, like here is for man's hand, and the force is in leftward direction. So that's why this option, oh sorry, this option is correct and this option is correct, and these options are incorrect in terms of force on man's hand. And what about on feet? Like it is towards the right, so towards the right is here and towards the right is here. So this one is incorrect, this one is incorrect. So overall the correct option is this one. Okay, now let's see the 13th number. In which situation is the resultant force on a body equal to 0? Okay, let's assume that this force F, like you know the formula, F equals to ma. So 0 is when acceleration is 0. You know that the mass can't be 0. Acceleration is 0. Acceleration is 0 when v is constant or object is in rest. Either the velocity is constant, or object is in rest state, then acceleration would be 0. Let's find out the possibilities in a given question. So you can see a car is turning a corner at constant speed. Speed is constant, but when it is turning, its direction changes. Like the magnitude, like it's not the velocity, it's speed. So there is a difference. If for acceleration it should be velocity. So the second thing is, when it is turning a corner, on a corner there is a change in direction, so that causes acceleration. So in this case acceleration is not 0, so that's why this option is wrong. Okay. A rock is falling freely on the moon. Like when there is a fall, there is a gravitational acceleration, so this is also incorrect. Okay. Aircraft accelerating, when there is accelerating means there is a change in velocity and acceleration is produced, so this option is also incorrect. Okay. A train going up a hill at a constant speed, like straight up a hill is a direction. Look at this, is a direction, and here is a speed. So speed plus direction is called velocity. So it means it is talking about velocity term. So and velocity is constant. So when velocity is constant, it means acceleration is 0. So you can say it's correct option. In number 14, it states a satellite is orbiting Earth. Like satellite means like it can be a moon, it may be an artificial satellite, so it can be anything. Satellite means the man-made satellite, which is called artificial satellite, and there is another satellite. This is a natural satellite, like moon is our natural satellite. What is the direction of force? So like whenever there is an orbital kind of thing, it means there is a centripetal force acting on that object, which causes to move it along the circular path. What is the direction of the centripetal force? Here is a force means centripetal force on the satellite, causing their circular motion. So you know that centripetal force is always directed towards the center. So it is always directed toward the center, and in center we have Earth, so it means the direction of centripetal force would be towards the Earth. So let's see, away from the center of the Earth. If it would be away, then it means it would not be orbiting, na? Like the force is trying to move away, then can it be towards the center? No, that's wrong option. The direction of motion of the satellite, like the force and direction of motion can't be parallel. It's a circular motion, not straight line motion. In the opposite direction to the motion of satellite. No, it's not a friction force which causes to move it. Like friction forces are always opposite to the direction of motion. So centripetal force is not a friction force. and we are left with only one option towards the center of that. That's correct. In question number 15, let's see the diagram. The diagram says, okay, the diagram shows a block. Here is a block of stone on a rough horizontal surface. Rough means there would be some friction maybe. Force P on the block as shown, like the P force is active. P means 10, 15, 20, whatever. There would be a number which is represented by P. The block is at rest. It means its velocity is 0. Friction force F acts on the block. Okay. Which row shows the direction and size of F? Okay. Now it is well understood that the direction of friction force is always against the motion. Like the applied force will, this P force will try to move the object in rightward direction, like this. And friction force will always oppose the direction of motion, so that would be in reverse direction. Okay. Direction of, this is the direction of F. Okay, direction of F is towards the left. So let's mark the left side. Here is the left side. Here is the left side. And this one is cross. This one is cross. Okay. And size of the friction force. Okay, more than P, same as P, same as P. Okay, so when like in this case the object is in rest state, it means like the acceleration is 0. Acceleration is 0 means like we have both possibilities, like it can be equal to it can be equal to, okay, actually it is more than P. If it would be equal to this, then it will start moving with constant velocity. So rest of the options are incorrect. So overall this option is correct and rest of them are incorrect. In number 16, it's a distance time graph, and gradient of distance time graph is speed. So the distance traveled by a car is increasing. Yes, with the passage of time the object is moving away from the, this is the original like starting point, and you can see with the passage of time the object is moving away from like after some time it would be here at some distance. So gradient of this one is speed, and it looks like this straight line type of graph is about uniform speed, velocity, acceleration type of thing. So uniform speed means, or uniform velocity means no change, or means constant speed or constant velocity. When we have constant speed or constant velocity, then acceleration would be 0. When acceleration is 0, okay, then it means force is also 0. Okay, so we have these two factors which are 0. Okay, let's see the distance traveled by a car driving along a straight line, on a road. It means its height is 0. When height is 0, it means its potential energy is also 0. Okay, one second. The distance traveled by a car is increasing uniformly as it is driven along a straight road up a hill. Okay, okay. Now we are left with only like speed is constant, and the question is which quantity for car is constant. Acceleration is 0, resultant force is 0, on a straight road potential energy is 0, and we have constant velocity. Constant speed means we have constant kinetic energy. So its kinetic energy is constant, like the question is about the constant but not 0. Kinetic energy is constant and it is not 0.